Thank you. That was my fish face. Good fish imitation, huh? Yeah. Okay. Today is a winky, as in W-I-N-K-Y, winky day. Yes, it is. You're going to want to know how to do these bad Larrys that I'm going to do on the board today. Trust you, me. All right, here we go. A couple of good force problems that would be really winky. Good to know. Okay, here we go. So let's say that we have, no. Really? No. Nailed it. Let's try that again. Right. Let's say you have box on table. Nothing new there, right? But this time, we are pulling box on table along table with maybe a rope or something like that. And you're applying force to the rope. I don't know, let's make up 300 newtons. 300 newtons of force. Which, by the way, force along a rope or a string is called tension. It's the same thing. Tension and force do mean the same thing. So we have this, we're putting some tension, some force on the rope. We have it at an angle. It's like you're pulling a slide. When you pull a slide, you don't actually put the rope down here and pull a slide. No, you pull up at an angle and pull. It's comfortable that way. But when you do that, you're actually moving the object in two directions at once. Yes, you are. Two directions at once. Yes, you are. You're moving it forward, and you're pulling it up. In fact, if you pull up too much of an angle, you'll lift the thing right off the ground, right? Because you're putting too much force up and not enough forward. So in this case here, let's make our angle 30 degrees. Maybe you're pulling the rope at an angle of 30 degrees. And that makes a right triangle. Yes, you know what's going to happen. Yes, you do by now, you know. The right triangle stuff just never goes away. All right, we're going to need to figure out both sides of this triangle. Now, earlier in a couple of videos ago, I did a problem like this where we're pulling up on it, but I said there was no friction. If there's no friction, then the only thing you need to know is that arrow right there. You don't need to know the arrow up. But there is friction in this problem. There's going to be friction in this problem. Let's say the coefficient of friction between the box and the table is 0.3. So I'll put mu equals 0.30. Okay, mu equals 0.30. So there's coefficient of friction there, so there's got to be friction. If there's friction, that matters. Yes, it does. So we need to figure out both sides. We'll show you why in just a minute, but we need to figure out both sides. Let's go ahead and go get that. So I use sine, this is the opposite. Sine is equal to the opposite over the hypotenuse. So I'd multiply a sine of 30. I'm not going to write down this time. I've done so many of these. If you're not sure how I'm getting these numbers, go back and watch sine, cosine, and tangent videos from before. But the sine, opposite 30 times 300, sine of 30 is 0.5. So 0.5 times 300 would be 150. This side will come out to be 150 newtons, Italian word. I have a lot of Italian words. Now what about this side? This is the adjacent side. I use the cosine of 30, which is 0.8660, and I'd multiply that by 300. So you're going to get, no, I don't know, like 260 or something like that, but let's do it. Let's see, cosine 30 times 300, 260, rounds right to 260. So 260 is that side. Okay, all right. Now, what else do we know about the crate? Well, we have to know the mass of the crate. Let's say the mass of the crate is 50 kilograms. So it's a 50 kilogram crate. You're going to pull it along the floor. We want to figure out the acceleration. Okay, typically that's usually what we want to do. So I'll put acceleration here, unknown. And do we have enough information? We have the force making it move. That's the force making it move. I didn't erase it this time. I actually left it up there. I was getting smart, this guy. So 260 is the force making it move. The force holding it back is going to be friction, unless somebody else is helping, which nobody else is helping in this problem here. So we have just friction holding it back. So friction is a force holding it back. Oh, the force of friction is 0.3, right? That's the force of friction. No, that's the coefficient of friction. Remember how to get the force of friction. F equals Fn times mu. So we are going to have to figure out the force of friction, because we are going to have to figure out the force holding it back. I know the mass, and I'm trying to figure out the acceleration. All right, let's see what we got. Force making a move, 260. Not 300, 260. Forward, making a move forward. Okay. So I don't have room up here, so I'll write that over here. So 260 newtons is the force making it move. Well, what's holding it back? Friction. Well, I haven't calculated the friction yet. I know the coefficient, so let's calculate the force of friction. This is where it gets a little fun. So the force of friction is equal to Fn times mu. Fn times mu. Now on a horizontal surface, which we are, horizontal table, Fn is Fw. Oh, so just figure out the weight of the box, 50 times 9.8, and we'll put that right in there. Boom, multiply by 0.3. Simple, easy. What's so difficult about this problem? Okay, all right, check it out now. Check it out. That is opposing the force of weight down. So I'm going to draw a weight vector in here for you. So draw a weight vector. We draw it from the center. Okay, that's usually where the center of gravity is. And I'll put my weight vector, and let's calculate the weight, Fw. Okay, what's that equal to? 50 times 9.8 would be 490. The force of weight is equal to 490 newtons. Oh, shouldn't that just go right there? It's on a horizontal surface, blah, 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 perpendicular, normal, same thing. You said that before. You did, I heard you. That is true. It would be 490 if it weren't for the fact that we are pulling up on the box with 150. If you pull hard enough in an upwards direction, you'll lift it right off the table, and there'll be no friction. So what you're doing is you're opposing the downwards weight force, which is generating some friction, because this is Fw usually, right, if it's on a horizontal surface. So that helps, weight is going to make more friction. But you're opposing it. You're pulling up on it. That's relieving pressure or tension down on the table. That eases up the amount of friction. So what we have to do is that we have to take these two vectors, which are opposite one another, one going down and one going up, and we have to, opposite vectors, subtract them. Yes, we do. Be careful. Remember, this is a winky day. Okay? Be careful of that. You got to remember that. So in order to figure out the friction here, it's going to be Fn. Now, Fn is not Fw because this arrow is pulling up, or pulling up and pulling away from the downwards force. So I have to subtract those two. So Fn is going to be equal to 490 minus 150. Then I can go ahead and multiply it by mu, which is 0.3. All right? That is going to give me my force of friction. Aha! Tricky, 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 you're tricky, you're tricky. Okay, subtract those two, multiply by 0.3, and you get 102. So the force of friction is 102 newtons. All right, now we're ready to go ahead and put that in for the force holding it back, right here. So force making it move, 260. Minus force holding it back, 102. That equals the mass times the acceleration. There's my setup to solve the problem. So 260 minus 102 is 160, 158. 158 equals 50 times A. Solving for A, 158 divided by 50, a little bit more than 3. So 158 divided by 50, 3.16. 3.16 meters per second squared. Okay, don't forget that if we're pulling up and we have friction involved, if we don't have any friction, this doesn't matter because it wouldn't oppose any friction, so it wouldn't matter. But there's friction involved, we've got to make sure we subtract that arrow from the weight vector. What would happen if we had the opposite? What if we were pushing the box along the table at an angle? We're moving it forward. Well, we'd have to construct our triangle, figure out this side here, call that x, and figure out y. Why? Because you have to. So you'd figure that out. And guess what? if you have the weight vector going down here, if you're pushing something along like this, you're actually driving it, part of your force driving it into the ground. So what would you have to do with that vector here to the weight? You'd have to add it. That would actually increase the amount of friction because you're pushing it into the ground. And force into the surface increases your friction. All right, so you would have to add that. Now, I'm not going to go through a problem like that right now because I just kind of did. It would be the exact same thing, except I would just have to not subtract like we did here. If this was 150, I would add the 150 to Fn and solve for the force of friction. So it's the same problem, except if we're pushing down, we add that vector. If we're pulling up, we subtract that vector from the weight. All right, okay, all right. Let's try one more problem here in this video that I think you really winky day should know. Okay, for those of you who get my hintage, you know what I'm saying. Yes, you do. And you're all relatively smart people out there. I know you are. Okay, so let's say now we have an inclined plane. No, inclined plane. Let's say I have an inclined plane. I like 30 degrees. Because I know the sine functions and cosine functions, so I don't have to do them on the calculator. Inclined plane, 30 degrees. You have box on inclined table. Okay. What you want to do is figure out how much force it's going to take to move that box up the incline at a constant, steady rate. So you just want to be able to push it up the incline at a constant rate. Okay, all right. So let's see. Let's say our box is 20 kilograms. Okay, so the first thing I would like to do is draw that triangle. Remember, from inclined plane video, you have to, for every inclined plane, draw the similar triangle. You're going to need all three sides. So let's do that. Let's draw that out. So here's Fn. That's Fn. This is Fw. This is Fp, the parallel force. That's a right angle. That's 30. Those two angles are always the same. They're similar triangles, so they have to have the same angles. And yeah, I don't even know, so I'm not even asking the question. Well, actually, I did actually ask the question. I told you what I want you to solve for, how much force is going to take to move up the inclined plane. But if I didn't do that, it doesn't matter. We don't have to look at the problem yet. If I know I have an inclined plane, before I even look at anything, figure out those sides because you're going to need them. Okay, so let's do it. 20 kilograms times 9.8 would be 196 newtons. So this force of weight right here is 196 newtons. All right, got that. Now, figure out these two sides. Okay, I'm going to use my right triangle, cosine and sine function for the opposite, sine of yeah, you know it by now, right? 0.5. The sine of 30 is 0.5. So 0.5 times 196, or half of 196, this side will come out to be 98 newtons. All right, okay, I'll do this one out. I'll write this one out. Some of you are probably going, oh, wait, how'd you get that? How'd you get that? And I would say, well, we've done enough of these. I hope you can figure out sine, cosine, and tangent function at this point, but let's do one more. If I want to get this side, it's adjacent to that angle. So adjacent, cosine, some old horse caught another horse. Cosine is adjacent over hypotenuse. So the cosine of this 30 degrees is equal to the adjacent side over the hypotenuse. So Fn equals that times that. So cosine is 0.8660, but multiply that by 196. 196 times 0.8660, 170. We're going to round that right off to 100, 8867 actually, what it is. Hang on. 196. Yeah, 170. All right, so 170. So 170 newtons is this side of the triangle. All right, now I've got all three sides drawn out. I've got them calculated. Now I'm ready to do the problem. Before I can't do anything with an inclined plane until I do that. So a lot of times I know it's an inclined plane, then I immediately just draw this out, do these sides, and then go ahead and go back in. Then I look at the problem and see what it is I'm trying to find, because I will need those. All right, what was I trying to get you to find? Okay, so what we're going to do is figure out how much force it's going to take to push this box up the inclined plane at a constant, steady rate. There's a good problem. Winky, winky. Here's why. One, we're moving it up the inclined plane at a constant, steady, non-accelerating rate. Okay, all right, we all remember what that means, right? If you're not accelerating, there's no unbalanced force. If there's no unbalanced force, the force pushing it up the inclined plane and going down the inclined plane are equal. They're the same. It's not accelerating. Doesn't mean it's not moving. It just means it's not speeding up or slowing down. So that means the force going up and the force going down are equal. So if we go back up here to our working equation, the acceleration is 0, right? We're not accelerating. That means these two things are the same. That means if I figure out one of them, I know the other. Force making it move up the incline's me. Whoa! Okay, me. I'm trying to move it up the inclined plane, and that's what we want to figure out. How much force do we have to push to get this to move up the inclined plane at a constant rate? That means the force is holding it back. Oh, I kind of just gave you a little foreshadowing there. I said the forces. The forces holding it back are equal to my push. What are those forces? What are the forces holding the box back? What's saying to the box? 9, 9, you shall not pass and you shall like it. Okay, which forces are saying 9? 2 of them. There are 2. Do you know which 2 they are? I want to move it this way. Gravity wants to move it this way. Gravity, FP, says, 9, you shall not go up the inclined plane. That was my German physics impression, German physics guy impression. How am I doing on the German physics? Thank you. Okay. So this is saying, no, you will not go up the inclined plane. What else is saying no? What else? What other force always says no when you're trying to move something? Friction. There are 2 forces holding it back. So let's go ahead. And I know that these are the same thing. I know they are. So the forces holding it back are 2 FP and the force of friction, because if I'm moving it this way, friction opposes the opposite way. So these 2 forces are the forces holding it back, trying to make it go, not up the inclined plane. Then I know that if I'm moving it up the incline with no acceleration at a nice steady rate, then I'm just equaling those. We have balanced forces. My push versus these 2 saying no. Let's figure those out. All I have to do is figure those 2 forces out. And then the answer to the problem is solved. And that, remember the original question? How much force do I have to apply to move it at a steady rate up the inclined plane? Okay, let's figure these 2 forces out, because once I have those, I know the answer to the problem. We already know one of them. We already figured it out. See, told ya, you have to figure those out. You're going to need them. Right away, I already have one done. Okay, so I'm trying to figure out how much force is holding it back. I have to add in friction. We're going to have to figure that out. Okay, I didn't give you a coefficient. You're going to need a coefficient here. I'll make the coefficient 0.4. Coefficient of friction between the box and the incline, let's say it's 0.4. It's a decent amount of friction. Okay, so maybe it's a rough surface on a wooden box and you were trying to push it up this rough surface. Okay, so what's the friction? Well, the friction is 0.4. No, that's a coefficient. Come on, remember, how do we calculate friction? FF, yes, very good, Billy. FF equals Fn. Ooh, Fn. We figured it out already. Boom. So we need to know what Fn is. Did it. We already have it to get the friction. Ooh, you see why you need to get those triangles solved, side solved right away? You're going to need them. So that 170 goes right here. I go ahead and I multiply by the coefficient, 0.4. And this is going to give me the force of friction that I need to get her done. So 170 times 0.4, 68. 68 newtons. That's the friction trying to hold it back. So, friction trying to hold it back is 68. Gravity trying to make it go downhill, not uphill, because we're opposing it. So we have to overcome that. The forces holding it back are 150, 166. So that's my answer. Why is that the answer? Because remember, once again, the question. How much force do I have to push up the incline to move it at a steady rate? Meaning no acceleration, meaning I have to overcome the forces trying to hold me back. Two forces holding me back are FP and friction. Now if I figure those two out, problem solved. All right, answer is 166 newtons. Okay, all right, winky winky, winky winky.